Okay, we are going to look at our second example, which is speed of sound in dry air. So the formula for this is V equals 20 square root of T. So this will provide a good approximation of the speed of sound V. So we use V for this. V is the variable for speed of sound. And T is the temperature of the air in kelvins. And we want to estimate the instantaneous, should say rate, not rat. So estimate the instantaneous rate of change of V with respect to T at T equals 273 kelvins. So basically, I want to look at average rates of change. So I want to look at average rates of change over time intervals that have one side at 273 and that shrink down closer and closer and closer to 273. And this time, really like the previous example one we did, we only looked at it from one side. We really should be looking at these from both sides and show that they kind of converge to the same thing. So we'll look at some numbers that are, we're going to start out kind of looking at smaller numbers that are close to 273. So I'm going to look at 273 up to 273.000, whoops. So 273.000, let's say 5. We'll look at that time interval. We'll look at the time interval 273 up to 273 point, let's use 4 zeros and a 1. And then let's look at one where we use 5 zeros. And like a 5. So we're going to figure out what do these values converge to, if anything. And then what we'll do is we'll approximate from numbers below 273. So we'll get those values, and then this will be approaching from 273 from points that are to the right of 273. Then we'll look at like, what about 272 point, say 3 nines and then a 5 up to 273. What about 272 with 4 nines, maybe another 9 up to 273? And then what about 272 with 5 nines and then a 5? And what hopefully, if good things happen, this last one here is when we're very close to 273 approaching from the right. This last one down here is when we're very close to 273 approaching from the left. And we're going to hope that those two numbers agree to like 3-ish decimal places. So we'll hope that those numbers are going to agree. So now I need to build my function. I'm going to put this in my calculator as y1. And we're going to use that same thing where you change your independent variable of your calculator over to ask. And then we're going to be able to use the table and type numbers into the table to see what happens. These are all based off of 273s on one side of the interval. So we're able to get away doing 20 square root of x minus 20 square root of 273. All that over x minus 273. So, oops, I've moved this over my face basically. So let's scoot that down. This is the equation we're gonna, let's put it up here. This is the equation we're gonna be kind of working with in this. We're gonna put this in our calculator as y1. And then all we have to do is type in these numbers into our table, and the calculator will handle the rest of it. So let me put this in my y1, so clear out what I got there. So we're going to put in 20 square root of x minus 20 square root of 273. All that divided by, make sure you get that all in parentheses, divide it all by x minus 273. And now I'm going to go over to my table and I'm going to type in my numbers. So 273.005, I get back 0.605 224. So then let's see what happens when I get 273.00001. I get back 0.605228. So let's see, how about 273.5 zeros, and then a 5, and I get back 0.605228 again. Okay, so that's, hang on, type that in wrong. 605228. Yeah. Okay, so we got that. Let's try the numbers that are on the other side. 272.9995. So we say, all right, what about 272.39's then a 5? That gives me back 0.6052278. How about if we look at 272.59's? That gives me back 0.605. 226. So let's see, what about if we got a 272.59's and a 5? That gives us back 0.605228. So the left and the right hand are approaching the same thing. They all agree 0.605228. They both agree that. So we're gonna run this. We're gonna just say, all right, well, our approximation's gonna be, we'll say the instantaneous rate of change. Instantaneous rate of change is about, I'm gonna draw this 3 decimal places and say it's 0.605. And then we got to think about the units. In these average rates of change, the top unit here is it's a speed, that's velocity in air, so that's meters per second. And then T is temperature in Kelvin. So the units of this, the top of this division, the units of these types of things here are meters per second, and the units on this is Kelvin. So it's going to be meters per second per Kelvin. So we could write it as meters per second per degree Kelvin. And this would be an estimation on that speed out to 3 decimal places. We maybe could get it out, ours agreed out pretty far, so we could have taken it to more decimal places, but we'll say 3 decimal places is good enough, and stop there.